So today we're going to be talking about logarithms. And the first question I want to ask is just simply, what is a log? What is a log? Okay, because logs are a bit abstract and take a little getting used to in order to understand. And I think the easiest way to approach this is to take something that's not a log first. So let's take the example, something that we're very aware of, just a simple algebra problem, 5x equals 45. All right, so how would we solve this problem? Well, we all know that in order to solve for x, we need to get rid of the 5, and the way we do that is by doing the quote-unquote opposite operation of multiplication. So we divide by 5 because we're multiplying here, divide each side by 5, and we get x equals 9, right? So in order to find x, we divided each side by 5 because the opposite operation of multiplication is division. All right. Now, what if, on the other hand, we have something like 3 to the x power is equal to 27? Now, how would we approach this problem? So, in the same way that we have 5x equals 45 and we divide by 5, there's not really an obvious quote-unquote opposite operation that we would use in order to solve for x here. So what we do is we actually use a log, right? So we say log base 3 of 27 is equal to x, okay? So we can understand logs as the opposite operation of a missing exponent, okay? Now, in order to solve this, we would say, okay, 3 to the what power is equal to 27? Well, we know that 3 to the third power is equal to 3 times 3 times 3, which is equal to 27. So that means that our missing exponent, right, our x, would have to equal 3, because 3 to the third power is 27, so 3 to the what power is 3, which means log base 3 of 27 is equal to 3. So a log is simply the reverse of an exponent, okay? And that's really the easiest way to understand it. Okay, so moving along. If we have some example problems here, say we're given something like log base 2 of 8. Okay. Now, if we want to go from log form to exponential form, then we say, okay, 2 to the what power is equal to 8. Okay. Because logs are always solving for missing exponents, okay? Because again, the whole purpose of a log is to act as the opposite operation of an exponent. So it's going to give us the missing exponent. So 2 to the what power is equal to 8. So then we can say that log 2 of 8 is equal to 3, because 2 to the third power is equal to 8. All right, so let's try one on your own. So say we have log base 4 of 16. All right, so take a second and see if you can figure this out. So hopefully you realized that logs give us exponents. So this means we're going to have 4 to the something power is equal to 16. Now, of course, we know that 4 squared is equal to 16, meaning that log base 4 of 16 is simply 2. And that would be your answer. All right. So that is our basic form with logs. All right. Now, we will also have to go from what's called exponential form into log form. Okay. And so this is kind of going the other way around. So say we have 5 to the x power is equal to 125. Okay. So how would we put this into log form? So go ahead and try this on your own. See if you can put this into log form. All right, so hopefully you gave it a try. And we would say that log base 5, okay, is equal to, oh, sorry, not equal to, log base 5 of 125 is equal to x, Okay, so as you can see, the 5 kind of comes over and matches with the x here. So we say 5 to the x power, right, and is equal to 125. So that's the way I like to think about it. It's sort of a small number, has raised to a power, 5 raised to a power, and then again, logs always give you the exponent. All right, now if we're going to solve this, we would say log base 5 of 125. Okay, so 5 to the what power? 5 times itself, how many times gives you 125? Well, we know that 5 times 5 times 5 is equal to 125. So that means this is 3 for your answer. 3. Okay, so let's try one of those on your own. So say we were given the problem 6 to the x power is equal to 36. All right, so try that on your own. Okay, hopefully try that on your own. And we would say that log base 6, because the 6 becomes the base, of 36 is equal to x, because logs always solve for your exponent. So what's going to be on the other side of the equal sign is the x. Okay, so we know that 6 to the what power? That means this is going to be 2, because of course 6 squared is equal to 36. All right, moving right along. Okay, so there's a couple instances when using logs where it's sort of helpful to have an understanding of the basic sort of solutions you will get with certain setups. Now the first one we'll talk about that with this is logs with fractions. Okay, so when we take the log of fractions, certain things start to happen, and again, it's nice to have a basic understanding of what sort of answer you're going to get, right? So say we have log base 3 of 1/9. Okay, now this is a log of a fraction, right? And this is equal to x. All right, so what happens here, right? We can sort of think about it this way. Again, we would bring the x over here, and it would come to the 3 to the x power, and then the 1/9 would sort of come over here. Sort of a helpful way of thinking about the circle here. And so what we would get with our setup is 3 to the x power is equal to 1/9. Now, how do we get from an exponential form to a fraction? All right. Well, the way we do that is with negative exponents. Okay. So 3 to the -2 power is going to equal to 1/3 squared. Because if you remember from exponents, anytime you have a negative exponent, it just travels to the bottom of the equation. Okay, so then we have 1/3 squared, which is equal to 1/9. 1/9. All right, so that means our answer will be x equals -2. X equals -2. Okay, so as a general rule, when you have logs with fractions, you're going to get negative answers. Okay, so let's try one of those on your own here. Okay, so we try this on our own, then we're going to get, let's see, log base 2 of 1/16. 1/16. Okay, so try that on your own and see if you can figure that out. All right, so hopefully you gave that a try. So what we're going to get here, okay, is 2 this is equal to x. So we're going to have 2 to the x power because this comes over here. It becomes a power, and then this comes over to your answer side. So 2 to the x power is equal to 1 over 16. All right. Now from there, okay, we say, okay, 2 to the has to be negative because we're going to need a fraction, right? And it's going to be 2 to the negative 4th power. And then that gives us 1 over 2 to the 4th power. And 2 to the 4th power is 16, so 1 over 16. So that means that x has to equal negative 4, because in order to have to get from 2 to the x to 1 over 16, x would have to be negative 4. Okay, moving right along. Another sort of instance that we'll have is when we have a log of 0 or of a negative number. Okay, so anytime we have the log of a 0 or negative number, basically it's pretty easy because we'll just kind of write it out to show you why this is, but essentially we're not going to get an answer. It's going to be impossible. So if we have log base 4 of negative 64 is equal to x, okay? So we'll bring this, have it be our exponent, and this will come over here. So our setup will become 4 to the x power is equal to negative 64. Now what you should realize here is that you can't have anything to a positive to any sort of power and get a negative number, because a positive times a positive times a positive, no matter how many times you go, will never give you a negative number. So this does not exist. The answer does not exist. It's not possible to be worked out. All right. It is similar to if we have, say, log base 5 of 0 is equal to x, okay? And then again, bring that here, and we have 5 to the x power is equal to 0, okay? And then that simply won't work, okay? Because you can't have 5 can't be raised to any power to give you 0. Okay. Now there are the next thing sort of talk about is a log of itself. Okay, a log of itself. So say we have log base 6 of 6. Okay, so we have matching numbers here. It's equal to x. All right, so what happens in this instance? So we have 6 to the x is equal to 6. Okay, so we have 6 to the x is equal to 6. Now, what happens if we have a number raised, or how do we get itself? Well, x would just equal 1, because 6 to the 1 power is equal to 6. All right, now, of course, this is going to be the same no matter what happens. So say you have log, 99 of 99, still going to equal 1, because 99 to the 1 power is equal to 99. So log of itself is always 1. Okay. And yeah, so those are really the special instances. Now let's talk about just some really notational things, right? And this is going to be log base 10 and log base E. Now, if you haven't heard of E, we'll go over what E is briefly. But basically, if you see something that just says log of 100, okay, is equal to x. Whenever you have nothing here, right, so there's no sort of base here to look at. Whenever that's the case, our base is going to be 10. It's assumed to be 10 if there's nothing there, okay? So that means this comes over here, This comes over here, and then we have 10 to the x power is equal to 100, so x would equal 2. Now, a nice trick when we have log base 10 and we have, like 100 or something with zeros like that, right, is you can just count the zeros, okay? So I'll let you give this a try on your own. So if we have log of 10,000 is equal to x. Okay, so see if you can figure that out and see if you can see the trick that I'm talking about counting the zeros. All right, so hopefully you gave that a try on your own, and we say, okay, this comes over here, this comes over here, and we imagine that we have a 10 right here. So we have 10 to the x power is equal to 10,000. Oh, sorry, one extra zero there. And so we would say x is equal to, well, we can count our zeros, right? So we have 1, 2, 3, 4 zeros. X is equal to 4, because 10 to the 4th power equals 10,000. All right, so that's just a nice helpful trick there. Okay, so let's talk about E. Let's talk about E. All right. So anytime we have something that looks like this, it's going to look like this, ln, okay, of 4 or something like that, okay? What this means is log base E, okay, of 4. All right, and this is often referred to as a natural log, okay? And all that it is a logarithm with a base of E. Now, E is a constant, okay? And it is called Euler's number, but really all you need to know is that it's 2.718 is E. So when you have this, it just means that you have a base of 2.718. And that's kind of that. Okay, now the last sort of special setup that we want to talk about is what happens when you have a log where the base is bigger than what's inside the parentheses. So say we have log base 36 of 6, okay, is equal to x. All right, now for practice, I want you to try to get this set up on your own. And if you want to figure it out, go for it, but just try to get it set up. So hopefully you try to set it up, and we'll have, okay, we'll switch to our circle, and we have 36 to the x power is equal to 6. Now this looks a little weird, right? How do we get from this big number down to 6 using a power? This is sort of contradictory, right? Well, we can say, okay, we know that the square root of 36 is equal to 6. And then we can also rewrite the square root of 36 as 36 to the 1/2 power. Okay? Anytime we have a fractional exponent, it's going to give us a root of some kind. When we have the square root, we imagine this to be like a 2 root, like that. So what this means is that for our original problem, we would say 36 to the 1/2 power is equal to 6, because the square root of 36 is 6. Okay, so this equals 6, which means that x is equal to 1/2. So anytime that you have a bigger base than your number here, right, you're going to have a fractional answer, So let's try one of those on your own. So say we have log base 256 of 4 is equal to x. All right, so try that on your own. Try to solve that and see what fraction we're going to get. Okay, so hopefully you gave it a try, and we'll see that, all right, this comes here, and what we're left with is 256 to the x power is equal to 4. All right, so what root do we need to do to get from 256 to 4? Well, we know it's a root of some kind, right? So we say 256, and we'd say, okay, 4 to the 4th power, right, equals that. So 4 root 256 is equal to 4, which means that 256 to the 1/4 power is equal to 4. Okay, which means that x is equal to 1/4. 1/4. All right, so anytime you have a bigger base than, bigger base than your number in the parentheses, we're always going to get a fractional answer. Fractional answer. All right, so that is really the basics of logs and setting up logs and working with